fundamental idea in physics is that nothing can be created nor destroyed. This includes energy and matter. This is a very badly created drawing of the River Nile. This is the Nile, these are the green areas that it was able to make bountiful, and these are the desert areas around it. The water is a type of energy that the farmers would use to energize the plants, which would cause them to grow, which they could then put into their bodies, which would energize their bodies. Again, nothing can be created nor destroyed, it is only converted. The water would only really help them in certain circumstances. One, the water needed to reach a larger area of space. They could grow many more crops if the water is spreading out. So what they did was they created irrigation, meaning that they would carve out areas in the land, trenches, let the water reach out in different areas. This is called irrigation, which was able to greatly spread the areas where they were able to plant plentiful crops and helped them to prosper. Again, they had to control the water in very particular ways. If they didn't control it in a way, if enough water was making it to the further areas, this guy would make plenty of crops in his very large amount of water. This guy over here further away would have a trickle and wouldn't be able to make good crops. They also needed to take care of the speed. I don't care how much water you've got. If the water was going too fast, it would just knock over the plants. And if someone had too much water in their area, then it would just turn their land into a swamp, which wouldn't be growing the kinds of things they wanted to grow. So what they did was made advanced irrigation systems so that they would let off water and current in a stable way so it could get where they wanted it to go, at the speed they wanted it to go, in the way that they wanted it to get there. Modern electronics do very much the same in circuits, and that is what we are talking about today. Electricity and Ohm's law. You see, electric energy running through a wire works like water rolling down a river. It will always take the path of least resistance. So in this way, creating a circuit is basically electric irrigation. Knowledge of the way that electricity works is vital to creating the technology-enhanced world that we live in today. Thankfully, a physicist named Georg Simon Ohm discovered a way for us to calculate and predict the movement of electricity in something known as Ohm's law, with a very simple way to remember it. This is Ohm's law. Let me explain it to you. This V represents voltage. Voltage is the amount of energy that is running through the wire. Think of it like how much water is in a riverbed. I represents current, which is basically how fast that energy is moving through the wire. And R is resistance. Resistance is whatever is slowing down the current. And Ohm's law says that voltage equals current times resistance. And you can figure any of these three as long as you know the other two. Voltage equals current times resistance, current equals voltage divided by resistance, and resistance equals voltage divided by current, which makes perfect sense. Also, resistance is measured in ohms, which their symbol looks like this, the omega sign. Current is measured in amps, and voltage is measured in volts. In creating a circuit, you can control the current by altering the resistance or the voltage. Let's say this is my little wire. It's a little sparse, it's just, some coil of metal. Let's energize it. We will put here a little battery. So now there's energy in the wire. So now we've got a very high voltage and a very low resistance, which means we'll have a rather high current. So here we will put a light bulb. Now the energy is being used to turn on the light, and the light bulb will give us some resistance because it'll be taking some of that energy. Overall current of the circuit will go down. Adding more sources of power will increase the voltage and increase the current. Adding more sources of resistance from objects that you're powering to a good old-fashioned resistor will reduce the current. Now, in our experiments, we will be using the numbers of voltage and resistance to figure out some circuit's current. So how do you figure out the overall resistance of a circuit? Well, there are two main types of circuits. The most straightforward type of circuit is one that we have here, a series circuit, where the items all come one after another in an uninterrupted line. And for a series circuit, if you want to find the overall resistance, you just add the resistances. It's pretty simple, but we might as well make it an equation. The overall resistance of a circuit equals R1 plus resistance 2 plus resistance 3 infinitum. Works the exact same for sources of voltage. The other main type of circuit we will be dealing with is parallel. It looks completely different, so I'm going to explain it to you. This is a parallel circuit, a circuit that splits apart and reconvenes in different paths. Electricity, just like water, will always find the path of least resistance. Whenever we'll come into the parallel section, will always come out. So what you're doing is you're basically dividing the added resistances by the different paths it could go. So these are the different resistances, and that's what you do. So the equation is 1 divided by RT equals 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. The other big type of circuit is a mixed circuit, which will have serial and parallel elements. Now the way you find this, because when you first think about it, it can be very scary. What are you supposed to do? What are you supposed to do? Actually, it's very simple. We are very smart people, and we figured this out. See, all you gotta do is treat the parallel section of the circuit like one component of a serial circuit. For example, this has 1 ohm, this has 2 ohms, this has 3 ohms, this has 4 ohms. Let's get rid of all this. So, 1 divided by 1 equals 1. 1 divided by 2 equals 0.5. And 1 divided by 3 equals 0.33 infinitum. Put this together, we get 1.83. 333. Now we divide 1 by this number. When we get 0.4545 infinitum, but we'll just call it 4545 for now. So, this whole thing has an overall resistance of 0.4545 ohms. Then we add it to this with a resistance of 4. And their overall circuit is 4.4545 ohms. And that is our circuit. I hope you enjoyed the video, and you can look down here for our results and discussion about this experiment.